Hi class, we are starting chapter 2 and we will get through most of chapter 2 this week, and next week we will cover the last section in chapter 2. So let's get started. We are going to be covering measurements in this chapter, and to help you understand how we're going to start using a different number system than what we are used to in regular life. So if you take a look here, we're used to, if you want to know what the weather is, then and somebody tells you 72 degrees Fahrenheit, you would instantly know what that means. But if somebody was to tell you 22 degrees Celsius, unless you're from other parts of the world who use the metric system, that would be very foreign to you, and you would be instantly thinking, what would be the conversion to it? So this chapter is to help you get introduced to the system that we're going to use, and also we're going to start doing conversions and calculations with it. Measurements, quantitative observations, fancy words for measurements, consist of a number and a unit. This is very important. You can never just provide a number, and you can never provide just a unit. We need to have both together to know exactly what you're talking about. If you were to do a problem for me and you gave me just the number and no unit, it would be wrong because I don't know what it goes to. Measurements in science, we use SI units and metric system units. So for instance, we use the meter, the gram, and the liter, but in everyday life, we might use yard, pound, and quart. Why is this important? Because in 1999, there was Mars climate orbiter, I'm losing my thought here. It was worth $125 million, and it was lost due to unit confusion. They believe that because the units don't convert over completely, for instance, as a 1-to-1, from US units to SI units, they believe it crashed. It did not it could not complete its orbit. It was measured shorter, I believe. So yes, this is a big example of something that can go incredibly wrong if people do not streamline a system for all to use. So we don't use US measurements, we use SI and metric units. So you take a look here, you can see the units of measurement. We have metric, we have liter, meter, gram, and Celsius, and seconds. And pay attention to seconds, it's an S, it's not SEC. I'll point that out as we start doing calculations. And then SI, cubic meter, kilogram. You'll become very familiar with all of these by the time this course is done. So let's start off with volume. Volume, we tend to use liter or milliliter. A volume is the space occupied by a substance. I consider it as a 3D because you take into account the length, the width, and the height of everything. So this is a volume that's occupied, but it is more in dimension of thinking about 3D surface, nothing flat. In this class, we will use 1 liter or 1,000 milliliters. But if you take a look at what we would use over in the US as a quart, the quart and the liter do not match up exactly. In fact, the quart is shorter by approximately 50-something mils. So these do not convert exactly. And we're going to cover some of that through calculations when we do calculations about how many digits we would use and so forth to try to decrease errors as much as possible in our calculations. But these things do exist. They do not cross over complete as 1-to-1. Length, we will be using meter or centimeter, millimeter. Length in the metric system, and SI is based on the meter. So if you see a meter stick, it's actually larger than a yardstick. So you can see yardstick goes up to 3 feet, but 1 meter goes up to 39.4 inches. Now, these also don't match up exactly. So if you ever have a ruler, one side is inches, the other side is centimeters. So you would be using the meter side of it. We don't look at the inches except for in this chapter and when we're testing about conversions. So 1 meter is 100 centimeters. 1 full meter here is 100 centimeters. We use everything at a base of 10. 1 meter is also 39.4 inches. 1 meter is 1.09 yard. And 1 inch equals 2.4 centimeters exactly. And I'll get into what exactly means later. The next one we're going to cover is mass. But I need to point out the difference between mass and weight. They are not the same thing. They are proportional, but they're not the same thing. Mass is a measure of the amount of material in an object. The SI system uses kilogram as the base unit. The metric system uses the gram as the base unit. We will tend to use gram more than anything else. The mass of an object measures how much matter is in the object. So when you think about the difference, what's the big difference between weight and mass? Weight has to do with gravitational pull. So it will be different depending on what planet you're on. So for instance, if you're on Earth, you weigh 110 pounds based on this picture. But let's say you go to the moon, you weigh 18 pounds because the gravitational pull, if I'm right, is 1/6 the gravitational pull of Earth. So it's different and your weight is considerably different. So there's no consistency with this. When it comes to mass, regardless of where you are, you will always be 110 or 50 kilograms. Why? Because mass is not the same as weight. Gravitational pull is not factored in. Think of mass as being the thickness of you or an object. It's the thickness, how much of that thickness exists. That's the mass. So I may and others may use weight, but what we really mean is mass. We focus on mass in chemistry and not weight. So mass is in gram and kilograms. The mass of an object is a measure of the quantity of material it contains. So it's a not scientific word, but I think of thickness, how thick and what you're made of. 1 kilogram is 1,000 grams. 1 kilogram is 2.20 pounds. So again, this one's not a 1-for-1, pounds and kilograms. And 1 pound is 454 grams. If you take a look over here at this balance, this is something you would have used had you been in person in class. This is what we weigh or determine our mass of substances or items in. And it's usually in grams. You see there's a little green G here. So this is a nickel, and the mass of the nickel is 5.01 grams, and mass is what we would say. Here are some conversions of SI units and English units. You can see here, if you were given a test, you would be given enough conversion units to help you. But to be honest, you're going to have a lot of learning and memorizing in order to successfully complete this class. And that's it.